Hi! In this lesson, we are going to discuss how the pilots communicate with the ground during the different phases of the flight. Communication is a core aspect in the fast-paced aviation world. Things need to happen quickly to avoid delays and optimize costs through sharing operational and technical information. Let's begin our discussion by analyzing what equipment is used to communicate. Every airplane has normally at least one VHF radio, but airliners usually have 2 or even 3 on board. This is the primary method of communication and is used worldwide. Pilots use the VHF radio to talk to ATC, to communicate with other aircrafts, for emergency transmissions, to discuss operational requirements with the company, and to get updated weather reports for the airports. A VHF radio receives the same type of frequencies as your car radio does, except the actual frequency will be higher, and an aircraft radio can also transmit, not just receive. Most aircraft tend to be equipped with an HF radio as well. It is normally used to communicate when flying in isolate and remote areas or for oceanic crossing. HF has a greater range than VHF, so that it can reach longer distances, but also carries a lot of static and background noises, making it a useful way of communication only when no other option is available. CPDLC, or Controller Pilot Data Link Communication, is another way to share information. Without getting into the details of how this system works, I'll explain its use. The communication is between the pilots and ATC only, and is done through written messages. As one can expect, this is allowed and used only for non-time critical communication, and, as anything else in aviation, it is heavily regulated. I will now talk about who communicates to the pilots, starting from when the aircraft is on the ground. Most airlines have a dedicated frequency for their base and destination airports. On this frequency, pilots can ask and discuss operational needs like fuel requirements, boarding and disembarking passengers, delays, parking bays at the airport, flight management issues, and any issue that needs to be communicated to the airline. Engineering support can also be sought in case of troubleshooting once airborne, even though this practice can depend on the policies of the airline and its type of operations. Communication among airplanes is very common when operating in a minor airfield or private and remote airstrips, where a tower and air traffic controllers are not available. This is what constitutes the so-called uncontrolled airspace. In this scenario, communicating among each other is fundamental to maintain situational awareness and safety. By talking to each other, pilots can arrange the landing and taking off sequences and get an idea of where every airplane is in relation to the runway. Communication among airplanes can be useful in many other situations, making this a fairly common practice. A worldwide emergency frequency 121.5 is also set up for pilots to report emergencies. Pilots, as well as ATC, continuously monitor this frequency in case someone is in need. Most airports have a dedicated frequency for weather reports, which can have different names depending on the airport and the specific services provided. This frequency is a listening-only channel. Here, pilots can hear the latest reported weather conditions for that particular aerodrome. They are normally updated every 30 or 60 minutes, and any time major changes occur. By listening to these reports, pilot can plan the takeoff and landing accordingly, and can develop an appreciation for possible challenging and hazardous weather conditions. Finally, the star of this show, ATC, or Air Traffic Control. Pilots need to maintain a continuous contact with ATC stations. Obviously, the exception is uncontrolled airspace, where this just isn't possible. Every time the aircraft leaves the area reached by a frequency, they will be directed to change frequency to the one that will cover the following part of the flight, maintaining continuous contact with the appropriate controllers. The airspace is divided into many volumes, defined both horizontally and vertically. Each volume will be covered by a frequency. During a flight, many of these slices of airspace can be crossed, and therefore many frequencies will be used. There are many types of ATC stations, depending from the type of airspace they control. I will just name the main ones and briefly describe them. Ground. Most airports have one or more ground frequencies to direct airplanes taxiing. Tower. This station manages the airport itself and gives clearances for takeoff and landing, making sure enough separation is given between airplanes taking off and landing on the same runway. Approach and departure. This can be one station for both phases of the flight, or two or more separate stations, depending on the airport and how busy it is. They handle the initial departure phase after takeoff and the final part of the flight before landing. Clearance delivery. This frequency is used to issue departure clearances to the pilots and slot times. We'll talk about this in another lesson. Center or control. These stations handle the airplanes during the cruise and whenever they leave the departure frequency or at higher altitudes. As you can probably notice, frequency management can be a handful at first, but through practice and over time, it becomes second nature. You should now have a clearer idea of how communication works, and I hope I was able to make you appreciate just how fundamental it is in aviation. See you in the next lesson.